Regents exam, Algebra 1, August 2016, problem number 6. The table below shows 6 students' overall averages and their averages in their math class. If a linear model is applied to these data, which statement best describes the correlation coefficient? Recall that the correlation coefficient measures the strength and direction of a relationship between two variables. In the case of a linear model, the linear correlation coefficient R is a number between -1 and 1 inclusive. The positive and negative signs are used for positive linear correlations and negative linear correlations, respectively. If the two variables, x and y, have a strong positive linear correlation, the value of R will be very close to +1. If R is exactly equal to 1, then this indicates a perfect positive fit, and the data will lie on a straight line with a positive slope. On the other hand, if two variables, x and y, have a strong negative linear correlation, the value for R will be very close to -1. If R is exactly equal to -1, then this indicates a perfect negative fit, and the data will lie on a straight line with a negative slope. Very rarely do linear models have an exact R value of +1 and -1, and will usually have values between -1 and +1. If R happens to be equal to 0, then there is no linear correlation, or if it is very close to 0, then we say that the data has a weak linear correlation. For example, the data can be random or have a nonlinear relationship between the two variables x and y. One way to determine the correlation coefficient is to plot the points in a coordinate plane and look at the pattern formed by the data, and determine the value of the correlation coefficient by inspection. If the data seems like it lies on a positive sloping straight line, then the correlation coefficient will be very close to +1. If the data seems like it lies on a negative sloping straight line, then the correlation coefficient will be very close to -1. A second way to approach the problem is by using a graphing calculator. Graphing calculators usually have statistic programs that can calculate the value for the correlation coefficient. Usually, this is done by first creating a chart or list that contains the values for one variable, in this case, the overall student average, and a second list that contains the values for the second variable, in this case, the math class average. Once the list is created, you can use a linear regression program to generate a regression equation, which will also generate the value for the correlation coefficient R. Please read your calculator manual or look up the steps required to use this feature on the graphing calculator that you will be using for your test. Usually, the program can be found under the name linreg. By using linreg, we obtain a correlation coefficient approximately equal to +0.92. By using this value for the correlation coefficient, along with the plot of the points we drew earlier, we can conclude that option 2 is the best choice.